That being said, let's get started with this study live session. In this study live session, I'll be doing chemistry. First chapter, some basic concepts of chemistry. That being said, let's get started. Importance of chemistry. Chemistry plays a central role in science and is often intertwined with other fields of science. Principles of chemistry are applicable in diverse areas such as weather patterns, functioning of brain and operation of the computer, production in chemical industries, manufacturing fertilizers, alkalis, acids, salts, dyes, polymers, drugs, soaps, detergent, metals, alloys, etc., including pneumatic. Chemistry contributes in a big way to the national economy. It also plays an important role in meeting human needs for food, healthcare products, and other material aiming at providing the quality of life. This is exemplified by the large-scale production of a variety of fertilizers, include a variety of pesticides and insecticides. Chemistry provides methods for the isolation of life-saving drugs from natural sources and makes possible synthesis of such drugs. Some of these drugs are cisplatin and Taxol, which are effective in cancer therapy. Cisplatin and Taxol are effective in cancer therapy that are AZT, acidothymidine, is used for helping AIDS patients. Acidothymidine, cisplatin and Taxol. Chemistry contributes to a large extent in the development and growth of nations. With a better understanding of chemical principles, it has now become possible to design and synthesize new material having specific magnetic, electric, and optical properties. This has led to the production of superconducting ceramics, conducting polymers, optical fibers, etc. Chemistry has helped in establishing industries which manufacture utility goods like acids, alkalis, dyes, polymer metals, etc. These industries contribute in a big way to the economy of a nation and generate employment. In recent years, chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. Safer alternatives to environmental hazardous refrigerators like CFCs, chlorofluorocarbons responsible for ozone depletion in the stratosphere have been successfully synthesized. Here, however, many big environmental problems continue to be matters of the great concern to the chemists. One such problem is management of greenhouse gases, like methane, carbon dioxide, etc. Understanding of biochemical processes, use of enzymes for large-scale production of chemicals, and synthesis of new exotic material are some of the intellectual challenges for the future generation of chemists. Biochemical processes, use of enzymes for large-scale production of chemicals and synthesis of new exotic material are some of the intellectual challenges for the future generation of chemists. A developing country like England is starting to encourage chemists for accepting such challenges. To be a good chemist and to accept such challenges, one needs to understand these concepts of chemistry, which begin with the concept of matter. Let us start with the matter, the nature of matter. We are already familiar with the term matter from earlier classes. Anything which has mass and occupies space is called matter. Everything around us, for example, the pen, pencil, water, air, all living beings, etc., are composed of matter. We know that they have mass and they occupy space. Let us recall the characteristics of states of matter which you learned in previous classes. States of matter. You are aware that matter can exist in three physical states such as solid, liquid, and gas. The constituent particles of matter in these three states can be represented as shown in figure 1.3. Particles are held very close to each other in solids in an orderly fashion and there is not much freedom of movement. In liquids, the particles are close to each other but they can move around. However, in gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. Because of such arrangement of particles, different states of matter exhibit the following characteristics. Solids have different volume and different shape. Liquids have different volume but do not have different shape. They take the shape of the container initially of fixed. Gases have neither different volume nor different shape. They completely occupy the space in the container in which they are placed. These three states of matter are interconvertible by changing the conditions of temperature and pressure. Solid by heating liquid, by heating gas, and gas cooling liquid, liquid cooling solid. On heating, the solid usually changes to a liquid and into liquid. Classification of matter. In class 9 chapter we will learn that at the macroscopic level or bulk level, matter can be classified as mixture of large substances. These can be further subdivided. When all constituent particles of a substance are in the same chemical nature, it is said to be a pure substance. A mixture contains many types of particles. A mixture contains particles of two or more pure substances which may be presented in any ratio, hence their composition is variable. Pure substances forming mixture are called as compounds. The substances forming mixture or all its components. Any of the substances present around you are mixtures. For example, sugar solution in water, air, tea, etc. are the mixtures. A mixture may be homogeneous or heterogeneous, and a homogeneous mixture completely mixed with each other. This means particles of components of the mixture are uniformly distributed throughout the bulk of the mixture and its composition is uniform. So the solution and air are the examples of homogeneous mixtures. In contrast to this, in a heterogeneous mixture, the composition is not uniform throughout, and sometimes different components are visible. For example, mixture of salt and sugar grains and pulses, along with some dirt or pieces, are heterogeneous mixtures. You can think of many more examples of mixtures which we can come across in daily life. It is worthwhile to mention here that the components of a mixture can be separated by using physical methods such as simple hand-dipping, filtration, crystallization. Pure substances have characteristics different from mixtures. Constituent particles of pure substances have fixed composition. Copper, silver, gold, water, and glucose are some examples of pure substances. Glucose contains carbon, hydrogen, and oxygen in a fixed ratio, and its particles are of same composition. Hence, like all other pure substances, glucose has a fixed composition. Also, its constituents carbon, hydrogen, and oxygen cannot be separated by simple physical methods. These substances can further be classified into elements and compounds. Particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. You may be familiar with the atoms and molecules from the previous classes. However, you'll be studying about that in detail in Unit 2. Sodium, copper, silver, hydrogen, oxygen, etc. some examples of elements. They are all atoms are of one type. However, the atoms of different elements are different in nature. Some elements such as sodium or copper contain atoms as the constituent particles, whereas in some other, the constituent particles are molecules, which are formed by two or more atoms. For example, hydrogen, nitrogen, and oxygen gases consist of molecules in which two atoms combine to get their respective molecules. When two or more atoms of different elements combine together in a different ratio, the molecule of a compound is obtained. Moreover, the constituents of a compound cannot be separated into simple substances by physical methods. They can be separated by chemical methods. Water, ammonia, carbon dioxide, sugar, etc. The molecules of water and carbon dioxide are replaced. Note that water molecule comprises two hydrogen atoms are present in a compound in a fixed. Thus, the atoms of different elements are present in a compound in a fixed and definite ratio, and this ratio is the characteristic of a particular compound. Also, the properties of a compound are different from those of its constituent elements. For example, hydrogen and oxygen are gases, whereas the compound formed by the combination that is water is a liquid. Wow. It is interesting to note that hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is used as a fire extinguisher. Properties of matter and their measurement. Physical and chemical properties. Every substance has unique or characteristic properties. These properties can be classified into two categories. Physical properties such as color, aroma, melting point, boiling point, density, etc. And chemical properties like composition, combustibility, reactivity, and with acids and bases, etc. Physical properties can be measured or observed without changing the identity or composition of the substance. The chemical or the measurement or observation of chemical properties requires a chemical change to occur. Measurement of physical properties. learn about the measurement of physical properties. Measurement of physical properties. Quantitative measurement of properties is required for scientific investigation. There are two different systems of measurement, that is the English system and the metric system, were being used in different parts of the world. The metric system, which originated in France in the late 18th century, was one more convenient as it was based on a decimal system. The late need of a common standard system was felt by the scientific community. Such a system was established in 1968 and is discussed in detail below. The International System of Units. The International System of Units, in French, les systèmes internationaux de units, abbreviated as SI, was established by the 11th General Conference on Weights and Measures. CGPM, from Conference Generally requires this at measures. The CGPM is an intergovernmental treaty organization created by a diplomatic trade union and Semitic Convention, which was signed in Paris in 1875. Maintaining the national standards of measurement. The system of units, including unit definitions, keeps on changing with time. We know the accuracy of measurement of a particular unit was enhanced substantially by adopting new principal members in member nations of Meter Treaty signed in 1875 agreed to the change the formal definition of that unit. Each modern industrialized country, including India, has a national metrology institute. National Metrology Institute, which maintains standards of measurements. This responsibility has been given to National Physical Laboratory in Delhi. This laboratory established experiments to realize the base units and derived units of measurement. Base units and maintains national standards of measurement. These standards are periodically intercompiled with standards maintained by other national metrology institutes in the world. International Bureau of Standards in Paris. The SI system has 7 base units, and they are listed in the table. These units pertain to the 7 fundamental scientific quantities. The other physical quantities such as speed, volume, density, etc. can be derived from these equations. What does it mean? 7 SI units? Meter, mass, kg, then meter, mass, kg, times, seconds, ampere, electrical, ampere, luminous intensity, candela, amount of success, mode, then mode, what is this? Temperature, Kelvin, that's it. Length, L, meter, mass, M, kilogram, kg. Meter, M, mass, kilogram, kg, time, second, S, electrical and ampere, A, thermodynamic, temperature, Kelvin, K, amount of substance, M, mole, luminous intensity, candela, C. The definition of SI base units are given in table 1.2. The prefix is a prefix to indicate the multiples or submultiples of n. These prefixes are written in table 1.3. Let us now quickly go through some of the pointers which you have in this book. Unit of length. The meter symbol M is SI unit of length. It is defined by taking the fixed numerical value of the speed of light in a vacuum to be 2997925 would be expressed in a unit meter per second, where the second is defined in terms of cesium frequency. Unit of mass. The kilogram symbol kg is the SI unit of mass. It is defined by taking the fixed numerical value of the Planck constant h to be 6.62607015 into 10 to the power of minus 34 when expressed in the units joules, which is equal to kilograms meter square per second. where the meter and the second are defined in terms of cesium frequency. The second symbol is a sign of time. It is defined by the decade, the fixed numerical value of the cesium frequency. The unportable ground state hyperfine transition frequency of the cesium 133 atom to be the phone. 91926317770 when expressed in unit hertz, which is equal to S. 91926317770. 91926317770. The ampere symbol A is a silent of electrical current. It is defined by taking the fixed numerical value of the elementary charge E to be 1.60217664 into 10 to the power of minus 19 and expressed in a unit C, which is equal to AS, whereas the second is defined in terms of cesium frequency. The Kelvin symbol K is a unit of thermodynamic temperature. It is defined by taking the fixed numerical value of the Boltzmann constant K to be 1.380649, 1.380649 to the 10 to the power of minus 23 when expressed in joules per joules per Kelvin, which is equal to kilogram meter square per second square per Kelvin. Well, the kilogram meter and second are defined in terms of Planck's constant speed of light and frequency, cesium frequency. The mole symbol mole is the scientific amount of substance. One mole contains exactly 6.02214076 into 10 to the power of 23 elementary entities. This number is the fixed numerical value of the Avogadro constant Na, when expressed in a unit per mole, and is called Avogadro number. The amount of substance symbol N of a system is a measure of the number of specified elementary entities. An elementary entity may be an atom, a molecule, an ion, an electron, and any other particle or a specified group of particles. The candela symbol CD is the SI unit of luminous intensity in a given condition. It is defined by taking the fixed numerical value of luminous efficacy of monochromatic radiation of frequency 540 into 10 to the power of 12 Hz Kelvin CD to be 683 when expressed in a unit 1 meter per watts, which is equal to candela SR per watts or candela SR per kg. Meters per square second cube. With a kilogram meter second are defined in terms of Planck's constant, vacuum, velocity of light, and cesium frequency. Perfect cesium, 10 to the power of minus 24 yocto. Yocto is 10 to the power of minus 24. Yeah, Zacto is 10 to the power of minus 21. Atto is 10 to the power of minus 18. 10 to the power of minus 15. Femto, 10 to the power of minus 10. Pico, nano, micro, milli, centi, deci. Deca, hepta, hecto. Deca, hecto, beta. Deca, hecto, kilo, mega, giga, tera, beta, exa, zeta, iota. 10 to the power of 2 is hecto, 3 kilo, 6 mega, 9 giga, 12 tera, 12 tera, 15 spectrum, and weight. Mass of a substance is the amount of matter present in it. While weight is the force exerted by gravity on matter. The mass of a substance is a constant, whereas its weight may vary from one place to another due to change in gravity. The mass of a substance can be determined accurately in the laboratory by using an analytical method. The SI unit of mass as given in table 1.1 is kilogram. Its fraction named as gram, kg equals to 1000 gram, is used in laboratories due to small amounts of chemicals used in chemical reaction. Volume. SI volume is the amount of space occupied by substance. Amount of space occupied by substance. It has the units length cube. So in SI system, volume has units of meter cube. But again, in chemistry laboratories, smaller volumes are used, hence volume is often denoted in centimeter cube or decimeter cube units. A common unit liter L, which is not an SI unit, is used for measurement of volume of liquids. 1 liter equals to 1000 milliliters. 1000 centimeter cube, which equals to 1 decimeter cube. In the laboratory, the volume of liquids or solution density. The two properties, mass and volume, discussed above are related as follows. Density equals to mass per volume. Density of a substance is its amount of mass per unit volume. SI unit of density is kg per meter cube. Is the SI unit of density or kg meter cube, inverse of meter cube. Density is more particles or molecules. Temperature. There are three common scales to measure temperature: Celsius degree, Fahrenheit degree, Kelvin. Here Kelvin is the SI unit. The thermometers based on these scales are shown. Degree Fahrenheit equals to 9 by 5 into degree Celsius plus. The Kelvin scale is related to Celsius scale. Equals to Celsius degree plus 50.15%. Negative values are not possible in Kelvin scale. Uncertainty in measurement. Many a times Reference standard. After defining a unit of measurement such as kilogram or the meter, scientists agreed on reference standards that make it possible to calculate a mass of vacuum emitting. Vacuum emitting. 1.6507637 into resistance the wavelength light emitted by krypton laser. Although this was a cubism number, it preserved the length of the medium and its agreed value. Similar to length and mass, the reference stands not the physical concept. Scientific notation as chemists use to study of atoms and molecules. It may not fun for a moment to write or count numbers involving so many zeros, but it offers a real challenge to do so. Simple mathematical operations of addition, subtraction, multiplication, or division of each number. You can write any two numbers of the above type and try any one of the operations you will accept as a challenge, and then you will really appreciate the difficulty in handling such numbers. This problem is solved by using scientific notation. Exponential, that is exponential notation in which any number can be represented in the form of m into 10 to the power of n, where m is an exponent having positive or negative values, and n is a number called digit term, which varies between 1 to 9. 1 term. Thus we can write 232.508 as 2.32508 equal to the power of 2 inside notation. these two operations follow the same rules except they're for exponential numbers. For these two operations, first numbers are written in such a way that they have the same exponent. After that, the coefficients are added or subtracted. Significant verbs. uncertainty in the experimental or calculated values is indicated by mentioning the number of significant groups. And the significant figures are meaningful digits which are known with certainty plus 1 which is estimated or uncertain. The uncertainty is indicated by writing the certain digits and the last uncertain digit. Thus, if we write a result as 11.2 ml, we see the 11 is certain and 2 is uncertain. And the uncertainty will be plus or minus 1 in the last digit. Unless otherwise stated, an uncertainty of plus or minus 1 in the last digit is always understood. There are certain rules for determining a number of significant figures. All non-zero digits are significant. For example, 85 centimeter. There are 3 significant figures, and in 0.25 ml there are 2 significant figures. Zeros preceding the first non-zero digit are not significant. Set zeros indicate the position of decimal point. So 0.03 as one significant figure. Precision and accuracy are often related to when we talk about measurement. has two significant figures. The result should not have more than two significant figures. So it is 3.1. While noting the result, the required number of significant figures is done in the above mathematical operation, one has to keep in mind the following points for rounding of the numbers. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1. If the rightmost digit to be removed is less than 5, the preceding number is not changed. If the rightmost digit to be removed is 5, then the preceding number is not changed, even if it is an even number, but it is increased by 1 if it is an odd number. Dimensional analysis. Often while calculating there is a need to converters. The method used to accomplish this is called factor label method or unit factor method or dimensional analysis. The case of metal is 3 inch. And this is the end of this study life session. We'll catch you up with another study life session. Have a small break. Have a Kit Kat. Bye bye.